As an alternative to drilling in place, what problem you have is when you're drilling through this 4 inches of wood, it's very hard to predict where the bit is going to come out at the other side. And you'd like to have the bit coming out precisely so that you can match the holes that are drilled in this crosspiece. In order to do that, then I've got this template. So if this was that end piece, essentially what I've got is this template, and you set it up flush with this end, and it goes back the center point is 3.5 inches in, and then you drill your holes. Now, since a drill bit will wander and you're not perfectly square, we're not operating with a drill press, you drill only about 3/4 of the way down. You come over on the other side, and this template is symmetrical in that regard, and position it again, and then drill your holes. And so now you've got a hole here, and then you come back in with a little bit larger bit, a chase bit, after you get these holes drilled, and you can seek around and find the other hole. So you have an inlet and access point that's at the appropriate dimensions. That will then match the end holes in this cross piece. So to make those end holes, I put the beam in the slot and drill the holes here, and those will give you the appropriate locations. So I'd start with a 1/4 inch bit, then I chase it with a 3/8, I think, to not make it too big, but to allow the penetration of the lag bolt. And then I come in with after that, was it 5/8 inch countersink hole to give a lead in. Because what we do is we'll put the tar on these surfaces, and it's nice to have a lead in, so as we insert the bolts we can kind of position and find the hole appropriately, and then drive it in with an electric screwdriver. So I wanted to mention the use of the template, and it's useful in this dimension, symmetrical 3.5 inches, and that's the depth at which I drilled these end holes to be able to put this cross piece in. So you can do it on both sides and match it up, and then it also serves the purpose of doing an end drill for these bits here, these pieces here. So I got a template, and it rests on top here, gives me the right dimensions, gives me level, and allows me to drill. So I start off with a 1/4 inch through the template, drill, and because we're out here and I don't have a drill press, it's hard to get everything square and parallel. So what I do is I only drill about 3/4 of the way on one side, bring the template over, it's symmetrical, put on the other side, drill in, get the 2 holes jointed up. So I use a 1/4 inch drill, go through and drill basically a pilot hole. Then I come through and I've got a 5/16 pilot bit. It's about 8 inches long, and I go through there and hunt through there just to make sure it connects with the other side. So we get a clearance hole, and then, so that's a 5/16 just to make sure all the holes get connected. So I got a straight through shot. Then I come in with a 1.25 inch paddle bit to drill these holes. I drill them down. How far do I go down with that paddle bit? I think I go down 1.5 inches into the wood. Let me check my notes here. Paddle bit. Yeah, I don't have the dimension here. I think it's 1.5 inches I drill in with the paddle bit. I just have a piece of tape marking on the shank of the paddle bit. So I drill in. The whole purpose is we'll get the head in here, engage it, just as you see here, and then I've got some curtain rod dowel wood dowel that I'll stick in the tar, jam in there, and then we'll just cut it off. And it gives a seal to all these heads, and just provides it a little bit more resistance to bugs and critters from getting in there. So what I do is the paddle bit go in 1.5 inches. So then once I get the paddle bit drilled in the proper sides, then I come through with a 1/2 inch bit and give a clearance hole. So I finish up with a 1/2 inch bit, goes through and gets a clearance hole. On this, these pieces here, these are the support pieces. I think I mentioned the dimension 21 inches. What I do is I have the template, fits over the end of this thing, gives me alignment. Again, 1/4 inch drill, and then I end up with 5/16 as the hole. It goes in, however depth, goes in about 3 inches for the lag bolt. And then what I do is I've got a 9/16 countersinking bit, and I run that in here to give me a lead in on these holes, just to give it a little bit of lead in, so when the bolts come in, my helper will hold this, and I come in here with a powered screwdriver and drive the bolts in. So that's that combination. The big thing I just wanted to kind of mention was the succession of drills and their sizes. Starting with the 1/4 is my primary pilot, and using the template. So that gives me all of that. Laying this thing out is pretty tricky. The biggest thing is you want to make sure that it's flat, and I chose to make sure it's level, and that allows me to ensure that it's flat. You can see we've got these metal barrels underneath for support, and then I've shimmed up all the wood pieces to give me a level workbench. The other thing that I've got going on here is when I first build this inside box, if you build this small rectangle and then try to build the bigger one, you can't get in there with your power tools. So it's easier if you build the larger rectangle, the inside box, and then add this extra beam in here. When I'm laying it up and getting ready to start to put the cross pieces on, I want to make sure I'm square, and to ensure that I'm square, what I did was measure the diagonals and go from the corner of this outside corner to the outside corner across to diagonal, and make sure that matches the dimension, roughly matches the dimension in the outside corner of this diagonal. If your diagonals match, then you got a square. If they're off, you can think of a rectangle or a square. You're basically perpendicular. You can think of this thing as if I could push, if I'm off in dimensions, it's like you squish this thing and it'll elongate these dimensions. Or if I pull this out, it'll shorten this diagonal. So if I was to go from that corner to that corner, that's going to be the same diagonal distance as it'll be from this corner to this corner. That's essentially what I'm doing. So
there you go.
You can think about it, if your diagonal's off, just think about squishing this way. It shortens the dimensions and it lengthens the other dimensions. It'll tell you whether you need to shift these things back or forth.